A warm welcome to everyone. Myself, Tanya, is from the Department of Computer Science and Engineering, Artificial Intelligence. I am from Sri Venkateswara College of Engineering, Bengaluru. So today's subject is about operating systems. The topic is multiprocessor scheduling in operator system. Firstly, the introduction part. Multiprocessor scheduling is a process of managing and allocating tasks to multiple processors in an operating system. The goal is to optimize resource utilization and improve system performance. So the main goal of multiprocessor scheduling is to utilization to utilize the optimized resource and improve system performance. It involves various scheduling algorithms and techniques to efficiently allocate processes to processes. The next is benefits of multiprocessor scheduling. There are three main benefits, namely improved system performance. Multiple processors can execute tasks simultaneously, leading to faster execution times. Increased throughput is the next one. Multiple tasks can be executed concurrently, resulting in higher overall system throughput. The last benefit is enhanced resource utilization. So, in this, efficient allocation of tasks to processors ensures better utilization of system resources. So, there are mainly four keynotes of multiprocessor scheduling. They are processor affinity, symmetric multi-threading, load balancing, and technique of multiprocessor scheduling. The next is types of multiprocessor scheduling. There are mainly three scheduling, which are homogeneous, heterogeneous, and global scheduling. In homogeneous scheduling, all processors are identical and tasks are distributed evenly among them. So in heterogeneous scheduling, processors have different capabilities and tasks are assigned based on their requirements. So in global scheduling, tasks can be migrated between processors during runtime to balance the workload. The next is primitive scheduling algorithms. In this, there are three steps. One is round robin. Next one is shortest job first, and the last one is priority scheduling. In round robin, each task is assigned a fixed time quantum and tasks are executed in a cyclic manner. In shortest job first, tasks with the shortest burst time were executed first, ensuring minimum waiting time. In priority scheduling, tasks are assigned priorities and the highest priority task is executed first. The next one is non-primitive scheduling algorithms. In this also there are three steps where first come first served, shortest remaining time, and the last one is priority scheduling. In first come first served, tasks are executed in the order they arrive without preemption. In shortest remaining time, similar to shortest job first, but the task can't be preempted once started. In primitive scheduling, tasks are executed based on their priorities, but preemption is not allowed. Next is load balancing in multiprocessor scheduling. Load balancing aims evenly distributes tasks among processes to avoid overutilization or underutilization. So in load balancing, mainly it focuses on overutilization or the underutilization process where it has to be avoided. In this, there are two types of balancing where one is dynamic load balancing and one is static load balancing. In dynamic load balancing, tasks can be migrated between processors dynamically based on their current workload. In static load balancing, tasks are assigned to processors during system initialization and remain fixed. Next is multiprocessor scheduling challenges. So there are mainly 5 challenges. There are synchronization, interprocessor communication, scalability, task dependencies, and load imbalance. In synchronization, it ensures the tasks access shared resources safely to avoid data corruption or race conditions. In interprocessor communication, efficient communication between processors for task coordination and data sharing. So in scalability, it ensures the scheduling algorithms can handle a large number of processes and tasks effectively. So in task dependencies, they manage dependencies between tasks can be complex or require careful coordination. Load imbalance, Uneven distribution of tasks can lead in underutilization of some processes, resulting in performance degradation. Next is real-time multiprocessor scheduling. In real-time systems require strict deadlines for task completion, making scheduling more challenging. So in real-time systems, it requires deadlines for task completion and making the scheduling more challenging, where it has to be very strict. So here there are two schedulings again. One is rate monotonic scheduling, RMS, and one is deadline monotonic scheduling, DMS. So in RMS, it assigns higher priority to tasks with shorter periods, ensuring critical tasks meet their deadlines. In DMS, assigns higher priority to tasks with shorter deadlines, providing deadline guarantees. So the next is advantages of real-time multiprocessor scheduling. Mainly there are three advantages, namely improved predictability, fault tolerance, and scalability. In improved predictability, multiprocessor scheduling allows for better predictability of task execution times and meeting deadlines. In fault tolerance, with the redundant processors, real-time systems can tolerate failures and maintain continuous operation. In scalability, multiprocessor systems can scale up to accommodate more tasks and handle increased workloads efficiently. So the next is multiprocessor scheduling in cloud computing. So how does this multiprocessor scheduling works in cloud computing? Cloud computing releases an efficient multiprocessor scheduling to allocate resources across multiple virtual machines. Virtual machine scheduling assigns virtual machines to physical processors based on resource requirements, load, and priorities. Elastic scaling dynamically adjusts the number of processes assigned to a task based on workload to demand. Next is future trends in multiprocessor scheduling. So there are mainly three future trends, that is machine learning based on scheduling, task migration, and heterogeneous processes. In machine learning, utilization machine learning algorithms to predict task execution times and optimize scheduling decisions. In task migration, dynamic migration of tasks between processes to balance load and improve resource utilization. In heterogeneous processor, scheduling algorithms can, which has to be considered the capabilities and the characters of different processors in the system. The last part is conclusion. Multiprocessor scheduling plays a vital role in optimizing systems, performances, and resource utilization. So various scheduling algorithms and techniques are used to efficiently allocate tasks to processors. Load balancing, synchronization, and interprocessor communication are the key challenges in multiprocessor scheduling. So these main 3 points is the main points which we have learned from multiprocessor scheduling. Thank you one and all. Thank you for this wonderful opportunity. Thank you.